Hello everybody, as promised, here is section 2.7, the last two problems. Please notice that the very first problem is talking about cost. Go ahead and pause the video to read this problem. So in here, they tell us that the derivative of cost is the marginal cost. And that's the instantaneous rate of change of cost with respect to the number of items produced. And we can use this a lot in economics classes. So if we're given a cost function here, and also keep in mind, I should note that the cost is in dollars, right? And they ask us to find the marginal cost. Well, that's easy. We just have to take the derivative of the function. And there we have it. For letter B, they say, okay, if we produce 100 items, what is the marginal cost? So then all we do for this is we're going to plug 100 into our marginal cost formula that we got in letter A. So it would look like this. And from here, when we plug that into our calculator, we would get approximately 13 cents per unit. Okay, now they also tell us to interpret this, meaning in words. What does this mean? Well, remember, the marginal cost means the instantaneous rate of change in the cost with respect to the number of units. So in this case, this is the instantaneous rate of change in the cost with respect to the number of units in terms of using 100 units. Let me write that down for you. And there I have it written for you. So go ahead and pause the video if you need to. In letter C, they want us to compare the marginal cost of 100 units being produced to the cost of, now letter C wants us to compare the marginal cost of 100 units with the actual cost of producing the 101st item. So we know that from the previous problem from letter B that the estimated cost here, it's about 13 cents. And then if we were to figure out the actual cost, what we would need to do is plug 101 and 100 into the original function for the actual cost. And when you go ahead and do that, you'll get these values in your calculator most likely. And there you go for letter C. Taking a look at example 4, we have a stone that's being dropped into a lake. Go ahead and pause the video and read that. But we want to find the rate at which the area within the circle is increasing at different times, 1 second, 2 seconds, 3 seconds. All right, so we are told here that our radius is growing at 60 centimeters every second. And let's just say t is in seconds. Now we know the formula for the area of our circle. And we are going to go ahead and plug in what we know r can be represented as. And we will get something like this. Now, if you take a look, the problem asks us to find the rate at which the area within the circle is increasing or changing, right? The rate of change. Well, the rate of change is the derivative, is it not? Please remember pi is a constant. So here we have an equation that represents our rate of change, and then all you have to do from here is plug in the times that they asked us to. So if you like, go ahead and pause this and plug this into your calculator. And there you go. And from here you can tell that as time goes on, the area is increasing at a faster rate, or it's moving faster. All right, I hope that helped you with the last two questions in our section 2.7 packet.